Okay, so let's have the first slide about me, since this is about my only opportunity to talk about myself to an audience who will actually listen, unlike what happens at fashionable parties. So here are a few frequently asked questions or frequently given answers about me. I'm a kernel maintainer of both SCSI and PA RISC. That means I'm sort of crazy into obsolete systems. I used to maintain Voyager as well, as David Early was just reminding me, but that ran across the ire of Ingo Molnar and got removed from the kernel a few releases ago. My day job is CTO of server virtualization at Parallels, so I'm one of the few people who actually has a day job that isn't quite playing with the kernel all day. I do get to spend about 50% of my time at Parallels' expense playing with the kernel, though. And Secure Boot, as you will notice, is pretty far away from what I usually maintain in the kernel. And unfortunately, I got into this basically because I didn't run fast enough when the crap was descending, and it landed on me. And I got stuck with actually trying to fix this on behalf of the Linux Foundation. And one other interesting fact that I keep getting asked about a lot, I did actually wear bow ties many, many years before Doctor Who made them cool. I suppose for the organizers of the conference, I have one other brief note. Someone actually sent me an email, I think the diversity officer, asking if I could make this slide set suitable for 12-year-olds. And I did think about it, but unfortunately I don't believe most of the concepts in here will be conceptually accessible to a 12-year-old. However, if you're 12 or under and in the audience and you actually understand what I'm saying, you can prove it afterwards, I'll give you an ice cream. Oh, and for Mr. Early, whose eyes just lit up, that means chronological age, right? I'm afraid you don't qualify. So here's the introduction. By the way, Dong Wei did a talk about UEFI Secure Boot yesterday. How many of you went to that talk? This tells me how fast I can go through all of this. Well, what were the rest of you doing? This means I have to repeat it again. Okay, so UEFI Secure Boot is a way of assigning static trust to the boot system of anything. It's not specifically tied to Windows. But it is mandated by Microsoft, and it has to be enabled in all shipping Windows 8 systems. The Microsoft mandate, which is what we go by, requires all the keys to be owned either by the OEM or by Microsoft, or I think we finally got an accommodation where the OEM can actually put some keys from third parties in there as well if they want. The Microsoft mandate does say that Secure Boot must be able to be disabled. So in theory, if you buy any one of these Windows 8 laptops, there should always be a switch in the UEFI firmware that would allow you to disable Secure Boot and actually get Linux up and running on it. But one of the things that the UEFI forum punted on was a standard way of actually doing this. So finding how to turn off UEFI Secure Boot is very platform specific. So I can't actually give you a demo of how to do it. I can show you how to do it on Tiano Core, but that won't help you with the flashy new AC you just bought. The key to UEFI Secure Boot, if you'll pardon the pun, are the keys. There are three sets of keys. One is the platform key, which is designed to be owned by the actual owner of the platform, the owner of the hardware. This is what Microsoft mandates should belong to the OEM. If you actually read the UEFI specs, it reads much more like it was designed to be owned by the owner of the hardware, which is the person who bought it, not the OEM who sold it to you. The next set of keys are the key exchange keys. These actually, anyone who owns the key exchange key can update the signature database and the forbidden signature database. So Microsoft mandates that at least one of their keys be in this so they can supply you on the fly with a list of blacklisted binary hashes and so on. And then finally, there's the signature database, which is designed to verify the trusted binaries. This is a slight lie because there are two halves of the signature database. There's DB, which is the allowed signatures, and there's DBX, which is the blacklisted signatures. And so the only way that you can actually boot something is if it's in the allowed signatures and not in the blacklisted signatures. And Microsoft mandates they have a key here too. In fact, they have three. I'll show you in the demo what they have. So it all works like this. The PK can theoretically only be used to update the key exchange key. But another thing the owner of the PK can do is they can actually move the platform programmatically into what's called setup mode, which is actually where it turns off all security, and you can manipulate the key variables on your own without actually any authentication. So the owner of the platform key actually can then forget about all of the, if you own the platform key, you can forget about all the BIOS menus and everything. Programmatically, you can actually flip the machine from user mode to setup mode and backwards and forwards again. Edit the contents of all of the keys and set up the system as you wish. I'll show you this in the demo. So if you take nothing away from this, it's when you get your shiny new machine, you should actually take control of that machine by replacing the platform key, because that allows you to basically take control of your computing future. Then, like I said, the key exchange key can only be used to update the DB and DBX, so that's actually the allowed and disallowed malware hashes. So this is sort of Microsoft's diagram of how the whole thing should work. And in Microsoft's view of the world, you own nothing in here. In my view of the world, you would own at least the platform key. So there's been an awful lot of confusion when we say UEFI Secure Boot. We don't actually mean UEFI Secure Boot as laid out in the specs from UEFI. We mean UEFI Secure Boot as mandated by Microsoft, and these are not exactly the same thing. A lot of the secure boot mechanisms that we're actually relying on are listed as optional in the UEFI spec, but Microsoft is mandating that they be implemented. So in theory, what we're actually doing is, in our systems, we're going by the Microsoft mandate that sits in the Windows 8 logo requirements. And that's not always the same as what the UEFI forum says it should be. So when I describe how some of these things are going, you don't necessarily get to blame the UEFI forum for them, you get to blame Microsoft for them. So some of these requirements are the OEM controls the owner key. This is, again, nothing to do with UEFI. This is a Microsoft mandate. UEFI has nothing to say about who should own the various keys. Like I said, Microsoft owns a key and the key exchange key. One curious thing about this, if you look at them, there are 3 keys in DB usually. One key is used exclusively for Windows and all of its binaries. Another key is used exclusively for all the third-party signing systems. It looks like Microsoft is setting it up so that if they actually wanted to revoke all of the third-party keys, they could do so without damaging the Windows boot. And then obviously on non-ARM systems, Secure Boot must be disabled via a UEFI menu, but on ARM systems, the reverse is mandated. So ARMs, Microsoft is mandating there be a lockdown with no way to remove it. They're non-rootable. And also on non-ARM systems, the user must be able to replace the key. Somewhere in your BIOS menu, there has to be a way of either removing the platform key, which tips the platform into setup mode, or actually just tipping the platform into setup mode itself. And again, there's no requirement for key administration or anything, so as part of the Linux Foundation effort on this, I've actually written a tool set which I'll demonstrate for key administration, which should make this an awful lot simpler. And an OEM can actually comply with the Microsoft mandate simply by having one option in BIOS that says erase all the keys. So it's important, if you ever wish to dual boot Windows again on this system, that you've saved a copy of them somewhere. GPL v3 and Secure Boot was a controversial topic. It's getting less controversial. Canonical were the only people who disagreed with this interpretation, and Mark held out on this for about 6 months for reasons that were never clear to me. But everybody now agrees with the statement that the way Microsoft has mandated UEFI Secure Boot, the Linux Foundation did an awful lot of work initially to get them to state this and to explain what the GPL requirements are. But as long as you have the facility for ejecting the keys from your BIOS and putting new ones in, nobody can be forced under GPL v3 to disclose signing keys. And Richard Stallman has signed off on this. So there is no danger of you being able to use GPL v3, say via the Grub bootloader, to go back to your distro and require the disclosure of their signing key. The ability for you to rekey the entire system is sufficient to satisfy the GPL v3 requirements. So here's the threat from all of this. Microsoft owns everything. The way the Microsoft mandate works is it's designed for a monolithic system, for a monolithic entity that controls everything from the OEM all the way on up to the operating system. Now, obviously, any monolithic entity would do, but Microsoft happens to be the only one in this position. Funny that. But since they have mandated it in this way and since we have to comply, the threat is that no Linux boot system would actually work out of the box on Windows 8. And it's actually a pretty nasty threat because by design, Windows 8 comes shipped with Secure Boot enabled. So if you insert a Linux CD into one of these laptops or a Linux USB key or whatever, the system will refuse to recognize it. It'll actually pretend it doesn't exist because you don't have the right signatures. This makes it very confusing for first-time users trying to install Linux, because the first thing that will go through their heads is, okay, my USB key or my CD is broken. This is why we need at least first boot media signed by Microsoft, so we can actually just get users back to the state where they can install their systems without having to know anything about UEFI menus, which are actually very troublesome to navigate. One of the key requirements that Microsoft puts on you before they will actually sign anything is that you're required not to boot any malware into the Windows system. This is where all of the complex secure boot requirements and patches to the kernel that you might have seen flying around come from. We're trying to design a system that can't be used to subvert Windows. And the other thing is that you have to obey all of their Windows 8 logo mandates. And these mandates go well beyond what the UEFI spec says. For instance, one of their mandates requires that you not have a present user test for booting something, for instance. And obviously, as I said, Linux will not boot on a Windows 8 system easily without us obeying all these mandates and Microsoft signing something for us to use as the bootloader. So the point is, for first boot for novice users, trying to explain how to disable secure boot in the UEFI menus is just not an option, because there's no standard menu option for doing this, and how you actually do this varies from laptop to laptop to laptop. And that just makes this problem too incredibly complicated for doing it. So we're forced effectively to have our bootloaders signed by Microsoft. Now, Secure Boot also comes with an opportunity. I mean, the opportunity is that it does give users a way of protecting their systems from external interference. Now, that external interference, since you can disable Secure Boot via a menu, means somebody remote from the system. If you have physical access to the system, you can't lock it down sufficiently. But it does facilitate Linux playing in markets where this is seen as a requirement. This is certain OEM markets like lockdown corporations. The defense industry is showing an interest in this. So this actually gives us a way of taking Linux into these environments. And to be effective in this space, you actually have to carry the root of trust all the way from the boot through the operating system and on down. So this gets us into things like, if we hand off to the grub bootloader and then grub boots a kernel, grub must check the signature of that kernel. If that kernel loads a module, we have to check signatures on the module. We have to disable certain regions of PCI space so the users can't use it to subvert the system, and so on and so forth. In theory, these allow the system to comply with Microsoft's requirement that malware doesn't happen to be a Linux kernel that quietly boots up using our bootloader and then has a root process that subverts everything and reboots into the malware. But it's also really required if we're going to play in the secure operating system space, because people who use secure operating systems to lock their users out of the system, which is a legitimate industrial goal where sort of IT has supplied you with a laptop and they want to make sure you don't alter it, requires something like this as well, because it prevents you from rooting the system. So here's the Linux response, and there are basically two challenges. The first one is to actually just keep the ecosystem booting easily in the face of secure boot. This one has been a bit of a failure at the moment, because there's almost nothing you can do if you've got one of these machines other than try and find the UEFI menus. We are getting there, but our release process was a bit slower than these systems came out. And then the other one is to actually find a way of enhancing security policy for distributions to take advantage of secure boot. We at the Linux Foundation have actually been concentrating exclusively on number one, just enabling the ecosystem to keep booting. The distributions themselves are investigating and preparing for two. And we think that's an appropriate split, because a lot of the value add in security is actually in option 2, but a lot of the enablement is in option 1. And the Linux Foundation's job is just to enable the ecosystem. And Red Hat and Canonical are actually already shipping secure boot systems in some form. So there are CD images, if you get the right ones, that you can actually load on these systems. It's just that the number of write images is very small compared to the number of CDs you get out of magazines out in the ecosystem, which is what makes it difficult for the users out there. The original Linux Foundation plans were to develop a set of tools that allowed you to both take control of the system and manage the keys, and also permit sort of the creation of signed binaries to reset the system. This was important, actually, if the OEMs accidentally forgot to obey Microsoft's mandate that we could remove the platform key. I can actually give you a binary, if I look at this system, that they can sign that will do this for you. So if any OEM ships a system that actually doesn't allow you to take control of it as contrary to the Microsoft mandates, we can fix this after the fact. And the final piece was going to be a pre-bootloader that would boot any unsigned kernel with a present user test. Now, if you remember what I said about the Windows 8 logo requirements, there is a slight incompatibility there, and we'll get onto this later. Here's what the distributions are doing. Red Hat has been interacting with the UEFI forum. They've created something called a shim bootloader. So it boots a signed second stage loader, which is actually grub2, which then boots a signed kernel, the kernel is locked down, and so on. SUSE came out with a different approach that was called machine owner key, which was actually a boot system that would allow you to install a separate set of keys of your choosing into it, and then it would boot based on those keys. These approaches are very consonant, and actually SUSE and Red Hat have worked together, and we've got a combined solution that actually says, it's called shim plus mock, which is where we use the shim for booting, and the machine owner key subsystem is actually integrated into shim. Both of these approaches require signing the initial shim binary with the Microsoft key, although we have some examples of this being done by now. Machine owner key, by the way, just means a new key list variable is actually called mock list. So there's now DB, DBX, and mock list. And the format of mock list is identical to the formats of DB and DBX, so all the standard tools work on it. Matthew Garrett has actually added a facility to store not only keys but hashes. So the difference between a key and a hash is that a hash authorizes a single binary. It's basically like the SHA sum of the executable components of that binary. A key authorizes a class of binaries because any binary that carries a hash and a signature from that key will boot in the system. So that means that keys are more flexible than hashes, but if you're an individual user authorizing your system to boot, hashes are probably the things you'll be dealing with because they're the easiest things to deal with. I should probably pause there and ask, was that explanation clear, or are there any questions about this? Okay. Shim will run the EFI binary if the key or the hash is actually either in the allowed signatures database or in the MOK list, and it's not in the forbidden signatures database. So it's basically the same check that a UEFI platform would do with an additional variable. Shim, the MOK list is actually what's called non-volatile plus boot services. All of the other secure variable are non-volatile plus boot services plus runtime. What this actually means is the variable itself evaporates as soon as you call exit boot services. The reason it evaporates is so that nobody who actually gets access to the kernel can modify this variable, because by the time the kernel is booted, it is gone. So the only way to modify the MOK list is actually from the EFI layer. So it can only be done by things that actually boot up at the shim stage. This is a slight lie, because the new way of booting the Linux kernel through EFI stubs requires that the kernel boot up with boot services enabled, and it will actually call exit boot services itself. So there is a short window where a properly signed kernel can actually get access to the mock list and could modify it. But the distributions are working on that. The final problem with shim, which I'll get into, is it actually only works with legacy link loaders like grub and FEBoot. It doesn't work with GummyBoot, which I see as a bit of a problem, but Matthew doesn't really care about because GummyBoot is not part of the current distribution environment. So here's the architectural problem that we actually have with the current shim solution. They overcome the UEFI signature check simply by taking a UEFI binary, and this entire shim is actually a link loader. So it loads the binary itself, it links all the sections, and then it just jumps to it and executes it. It's allowed to do this. So it doesn't rely on any of the boot services that would actually do signature checking. So it means that shim is a link loader itself, and it can only boot other things that are link loaders. The only reason grub would work with shim is because grub will take a kernel image and it will actually link it and boot it as well. And the reason it won't work with Gummy Boot and the new generation of bootloaders is because the new generation of bootloaders have decided that link loading is old hat. They don't want to be link loaders anymore. They want to be wonderful sort of UI things that then just call boot services load image. And the problem here is that even if I boot Gummy Boot, if it's going to call boot services load image on the kernel, what that's going to do is it's going to check whether the kernel's key is in the signature database, and it won't do the MOK check. That means there's no way to get from shim into Gummy Boot to boot a kernel that's verified by the MOK list, which means that suddenly there's no way of actually intercepting the secure boot environment again. We discovered this problem in around, so I did this talk at Barcelona in November, and somebody reported this problem to me in December, the beginning of December. This meant that all of the slides I'd given in Barcelona how we were going to do this were suddenly wrong, because I stated my mission as enabling the Linux ecosystem, and Gummy Boot is part of the Linux ecosystem. If I can't get this to work, then we actually don't have a solution according to my terms. So we have actually completely rewritten the solution the Linux Foundation did. And what I'll be showing you here is the newly rewritten solution. And then there are another few annoying screw-ups. UEFI redefined the authorization returns, I think, between the B and C revisions of the spec. And it now means that a binary that refuses to run can either return EFI access denied or EFI security violation. I'll actually show you this in my latest Tiano core image. When I try and execute unauthorized binaries, it's going to return security violation. Almost all of the shim solutions out there are checking for EFI access denied only before they do the mock check, because otherwise they assume there was some other problem, like we couldn't find the binary or something else, and they just crap out. What this means is that shim does not actually run on the latest Tiano core image because it's returning security violation, not access denied. This is obviously trivially fixable, but it means that there's going to have to be some update when the next generation of hardware comes through, and it's just something to be aware of. So here's the new architecture. So now, previously I'd done the same thing as shim. I had a link loader as part of my pre-bootloader, but I can't do that anymore. So what I'm actually doing instead is intercepting something called the security architecture protocol. This is in some ways a dangerous thing to do because the security architecture protocol is not in the UEFI spec, it's in the UEFI platform initialization specification. There's no guarantee that manufacturers will actually adhere to this specification, but in fact, as far as we can tell, every laptop we've seen in the field does actually adhere to the platform initialization specification as well. The problem here is that Microsoft does not mandate that you shall adhere to this. So I'm just relying on the fact that UEFI BIOS manufacturers are doing the decent thing, and actually they're looking at all the specs they're supposed to implement when they implement the hardware. But like I say, it's worked so far. There is a slight problem in that the 1.1 version of the platform initialization spec said you do it one way, and the 1.2 version said you do it another. The Tiano core image I have is 1.2, and it uses the Security 2 Arch protocol. Almost every machine in the field is 1.1, and it uses Security 1 Arch protocol. But all it means is I have to install 2 intercepts, and I expect one or other of them will actually work. So what happens now is that our pre-bootloader becomes a resident part of the UEFI runtime, and it does an intercept on the authorization handler, and so we can actually use the load image boot services because now we can actually, after the fact, plumb the MOK check into this. And I've redesigned the entire bootloader to do this. The problem now is that my bootloader's sort of stub is sitting in the DXE architecture layer of EFI. I can't take control of the console anymore. I cannot pop up any present user tests. So long before Microsoft got around to telling us they didn't like this approach, we'd already figured out this approach just wouldn't work anyway. Because now I have to have the binary pre-authorized. So the new architecture is actually almost the same as shim. The only difference between my loader and shim is that I don't have the whole of OpenSSL in my loader, so instead of being 1.5 megabytes, my loader is about 100 kilobytes. But I do have a SHA-1 test, so everything in my loader is authorized based on hashes. Although I have thoughts about how I would actually validate signatures to do with the, there's actually a key management mandate in the UEFI spec that I think we might be able to do this, but that's a topic for another talk if we actually play with this. But the good thing is, because the pre-bootloader installs a resident stub that intercepts the architecture protocols, Gummy Boot will now work, because I can now actually authorize something that will use BS load image. And so this is good. And Gummy Boot required a couple of patches, because what happens is Gummy Boot tries to load and execute the kernel, and it gets back a security violation return. Gummy Boot has to print a message saying, okay, here's the path of the kernel. I need you to add this signature to the MOK list, because otherwise I can't boot this kernel. Please, Mr. Booting User, could you go away and do that? That's all it required. And I'll demo this. So our pre-bootloader now has a couple of ancillary programs. It didn't used to have these before. It used to be a single program. Because now I actually need a hash tool that will actually allow me to add the hash to the MOK list. And I don't really need it, but I want to encourage users to take control of their system. So I also ship with a key tool that actually allows you to manipulate all of the key databases on the system. And by all of the key databases, it means the platform key, the key exchange key, the signature database, the forbidden signature database, and the MOK list. So all 5 key databases can be manipulated by this key tool. The other thing I wanted to do, since I want any distribution to be able to do this, is I need the security of this system to be transparently auditable. Matthew Garrett released a copy of Shim that had a key that he promised he'd thrown away that he used to authorize the mock variable editor, which comes along with Shim. But in order to audit the security of that, you have to trust his word that he threw away the key, which certain aggressive people in Debian security say are unwilling to do. So my system is completely open. It's built by the Open Build Service. You can look at the source that goes into the build service. You can see the binaries that come out of the build service. You can do the SHA-1 sums of those binaries, verify they're the same binaries that I gave to Microsoft to sign. And you can transparently see that in my preloader, I have 2 built-in hashes, one for the key tool and one for the hash tool, and that's it. So you can verify in a transparent way that my system will actually build and run, and it will only do what it's supposed to. So transparency of security auditing means that this system should, in theory, pass the security checks of almost any distribution without them having to get their hands dirty and deal with Microsoft, because I did that for them. So the other thing I'm likely to get questions about is the interactions with Microsoft. One of the reasons that we've been mucking about for about 3 months now isn't just the fact that I had to rewrite the whole thing from scratch. It's also due to the fact that the shipping UEFI systems happen to ship with a number of flaws. One unfortunate flaw is that my key tool, and I'll show you to it later, has this delete option for all of the keys. And if the platform's in secure mode, it's supposed to return a security violation and not let you delete the key. There was, unfortunately, one system that if you actually press delete on a platform key in user mode, which is supposed to be the secure mode, it would just delete the platform key and go into setup mode. And Microsoft found this. It was actually an Intel Tunnel Mountain system. It was the one they were using to check all the binaries on. Oh my God, they went nuts. I got this huge lecture about not using the Linux Foundation to subvert the UEFI Secure subsystem just because we happen to have found bugs in the EFI implementation. And I'm going, but I coded to the spec, you have a wrong implementation. But so the whole system had to be rewritten again so that I take into account there may be bugs in the system and I don't rely on authentication failures. I actually do the checks for Microsoft, otherwise we wouldn't get our key signed. So this is something to do with the politics of all of this, and this is why we've been in trouble. The other problem is that now, because Microsoft discovered us doing this, we've got our Microsoft signing account flagged, which means that every time I send a binary in for signature, they basically take a hammer and an entire test team over it, which they've whined about. So apparently I'm costing them a lot of resources because they insist on doing all these checks. But it means that the authorization takes at least a couple of weeks. I actually have a bootloader that we think will be the final one, and it went to Microsoft for signature on the 21st of January, and it's still sitting there in their security audit. It's a good sign because it means they haven't found a way to break it yet, but I still haven't heard from them that they're willing to sign it. So, are there any questions before I actually proceed to the demo? All of this is available, by the way. All of my tools are in the OpenSUSE build service, and I also have a Git repository for the EFI tools. If you actually look, this is build.opensuse.org. I have OVMF, which is the Tiano core image. You can just install that. It also comes with an EFI shell and a hello world. I have my EFI tools, which include the key tool and various other things to lock down the system and change it and take control of the variables. The others are all to do with code signing. A lot of the Microsoft code signing was very Microsoft specific. You have to produce a cab file and you have to sign that cab file. So LCAB and OSSL sign code are the ways we do this on Linux without actually having to trust Windows. And the P sign and SB sign tools are the way we sign EFI binaries. So we have the entire suite of tools in there. Oh, and GNU EFI is the build system for actually building EFI binaries. Okay, so any questions before I proceed to demo?
You mentioned SHA-1 a lot. Why are you using SHA-1 in a new system?
We're not. We're using SHA-256. That was a mistake on my part. Okay, so let me see. Let me not do that. Let's see if I can. Yep. Okay, so let's do the demo. So this is This is Tiano core booting up. Good. It's going to boot up into a secure system. I have on the system, sorry, need the key in it. These are basically me locking down the system because Tiano core comes by default with no keys installed. So I'm actually installing Microsoft's key exchange key, a set of authorization keys from Microsoft. This is actually my authorization key for DB because otherwise I can't demo this. So I have signed binaries and unsigned binaries. And then finally you lock down the system by installing the platform key. So let me show you an example of this in action. So I have an unsigned key tool. If I try and execute it, it just reports a security violation. Note it reported security violation, not access denied. This is the return problem again. But I have a signed version of this as well that will actually work. And so I can show you the keys. So the first thing you should ever do if you get a system is to go into save keys, because if the system decides that it's going into setup mode by erasing all the keys and you want to boot Windows, you will need copies of this later. So you can actually save all the keys to a flash storage device. So that one's an actual USB device that I have on the system. And it just writes them all to a file. And you can find this file in the top level directory of that USB system. That means that you have all of the keys from this system preserved. The next thing you can see is that my platform is in user mode and secure boot is on. So this is a fully locked down platform. And so if I look at the platform key, I've already taken ownership of this. So this is my platform key. As you can see, it belongs to me. But there's no actual delete option now in this menu. All it allows me to do is delete it with a .auth file. Now, when you install my EFI tools, it will actually build you a set of directories that will construct on the fly keys for the platform key, the key exchange key, and the DB key. And it will also include a file called nopk.auth, which is an authorized update to delete the platform key. So I can demonstrate that now, because I have it actually installed on the system. So these are the key directories that I did. This is nopk.auth. As soon as I do the update with that, the platform shifts straight into setup mode and secure boot is off. So I can programmatically take the platform now, because I own the platform key, through from user mode to setup mode. This now allows me to edit all the keys. So let me show you. This is the key exchange key database. That is a genuine Microsoft key exchange key, as you can see. I now have a delete option on this key because I'm in user mode. This key allows Microsoft to actually tamper with DB and DBX. So if I don't want Microsoft to do updates to this platform, I can just delete it. And now if you look at the key exchange key variable, it's completely empty. But obviously someone has to be able to do these updates, so I'm actually going to add my own key here. Let's see, can I find my own key exchange key? There it is. So if we look at this again, now I own the key exchange key in the platform. If I wanted to be nice, I could actually have co-ownership of that with Microsoft. I can add multiple keys to this. The other thing I can do is I can look at the database key. So you can see that I have a key in there, but by Microsoft mandate, they have 3 keys in there as well. So I could delete that if I wanted to, and delete that if I wanted to, and so Windows 8 will now not boot on this platform, but Microsoft can't run any binaries there as well. You have to be very careful before you do this. You have to know what you're doing. A lot of OEMs will have aftermarket option ROMs and things that are signed possibly by the Microsoft key. So you have to be aware that deleting all the Microsoft keys may mean that suddenly your video card might work or other elements of your system might work. Fortunately, a lot of the OEMs and ODMs have been finding Microsoft almost as difficult to deal with as I have. So a lot of them seem to be resorting to the option of actually putting their own key in here and signing all of the EFI things with their own key instead of relying on Microsoft's keys. But that's not behavior you can rely on. But fortunately, since you did that, you saved the key, you can actually put back all of the keys in the key signature database just by doing an add new key, and you can find the keys, and somewhere in this key directory I have a set of the MS UEFI keys, and I can put them all back in the database again. So I can take it back to the state where it will actually boot Windows. Okay, let me put this system back into secure mode, and I do that just by adding a platform key. So there's the pk.auth file. So you can see now the platform is in user mode, secure boot is on. If I look at any of the keys, I can no longer delete them. I can just, the only option I have is to save them, which isn't much useful, except for the MOK list. There I can add a new key, I can replace it, I can delete it, I can actually enroll the hash of a binary from the key tool. So DB and DBX also include the option in setup mode to actually enroll hashes, so you can manage your own blacklist straight from this tool as well. But anyway, this is not necessarily what the standard user will do. So let me kill this and let me show you what a standard user will do. So ideally, you would have installed pre-boot as part of the EFI boot subsystem. Ordinarily, this would be bootx64.efi, but I can't do that with Tiano Core because it will execute that in preference to my shell script that's locking down the system. So you'd actually just see boot up in an unsecured system. So I've just got this in a different place from where it would usually be. So it tries to start loader.efi in the same directory. Obviously, because my MOK list was empty and I have no signed binaries in that directory, it doesn't work. So this is what the user will see by default. And what it says is I couldn't start the loader. It should be called loader.efi. Please enroll its hash and try again. And I'll now execute hash tool for you to do this. So it executes hash tool. First option is enroll hash. So you can see this is the /EFI/boot directory, 4 binaries in there. There's the key tool, the preloader, which is the one I just executed, the hash tool, which you're running, and loader.efi, which is the bit that I need to execute. So if I just select that, it gives me its hash. I would usually be very cryptographically secure and verify this by external means, but I'm just going to authorize it. And now when I exit for key tool, preloader will go round again. That's gummy boot. And it's actually going to try and execute a Linux system. But obviously, this kernel also is unsigned. So in about 1 second, it's going to realize there's a security problem. 1A is security violation. It doesn't give us a text message because the GNU EFI, this is too new an EFI return for the GNU text things. So it told me the path of the loader I had to enroll, and it said, please go away and do this. So we come back to preloader again. It says, OK, something went wrong. Do you want me to start hash tool? So yeah, I say start hash tool. I enroll the hash. This time, the Linux binaries are actually in a Linux directory down here. And I think I was booting the 369 kernel, so I'll authorize that one. So I add its hash to the MOK list. I try booting again. There's 369. And this time, we should get the Gecko boot screen of SUSE. So I've used gummy boot to actually boot a Linux system. So in the remaining 7 minutes, I'll also illustrate there are some interesting things you can do with this as well. One is that if you noticed, in one of the options for gummy boot, I actually had a shell.efi. The OVMF build in the build services will actually build you an EFI shell. Microsoft mandates that no one should ever have a signed EFI shell, but you can use the same mechanism to actually authorize that this shell be assigned and runnable. Because by default, none of your EFI laptops that run Windows 8 will actually come with an EFI shell. And the EFI shell is actually a very useful thing. So let's show you, let's show the system doing that. Actually, let me just run it like this. So, oops. So we enroll the hash of the loader. Now I'm going to be smart because I know that I have to enroll the hash of the shell as well. The shell is sitting down here. There's the UEFI shell I put in here. So I authorize it by its hash. Now I come out of it, and Gummy Boot actually has an option to boot the UEFI shell because I added it to the system. We'll boot that. We won't allow it to do the startup. And this is an UEFI shell that's actually aware of all the MOK variables. So I can try and run Hello World, which is sitting in, let me get to FS0. An unsigned version of Hello World, which actually gives me a security violation error. I can start an unsigned version of KeyTool because that's already pre-authorized. I can edit the keys. I can go into the machine owner key list, and I can enroll the hash of a binary from my QEMU disk. And Hello World is sitting down there. So I can authorize Hello World to run. So as you can actually see, my mock list is getting quite large now, and I have 3 signatures in there. I can come out of this, and I can run the unsigned version of Hello World in the UEFI shell, and it works. So this actually allows you to use the MOK authentication system to run a full UEFI shell. So this is about the end of my demo. If there are any questions, we've got 4 minutes remaining. I'll take them now.
I'm just confused as to how many of those steps my dad would have to do when he sits down with his, a USB key of his new Linux distro on his new laptop.
He would have to do, well, it depends on the bootloader. The system can actually be set up to be very nice. The bootloader can do everything for you. So in theory, the only step you might have to do is to enroll a hash of loader.efi. And the system is very carefully set up to make sure that it's the hash tool in the directory where loader.efi is. And so all you have to do is select that, press enter, and press yes. I think this is almost identical to a present user test, but Microsoft is happy to retain the fiction that it's not. So this is the compromise we've reached. So it's not as simple as it could be, but it's not astonishingly complicated either.
Can I ask then, what does the user looking at a Windows 8 laptop, how do you get this into the hardware so that you can access this level?
Well, you'd have a signed preloader and you'd install it in UEFI boot. So as soon as you inserted the CD, let me go back to a pristine system. Okay, I need to come out of QEMU. Nope. Let's kill that and restart it so that it works again. What you'd actually see when you inserted the CD is what I see from the preloader screen. So it's come on, come on, come on. Yep. So this is the boot screen you'd see. And as soon as you inserted the CD, you will see that, because this will be signed by Microsoft. And so it's going to lead you as best it can through the steps you actually have to do to get Linux to boot. So as soon as you've inserted the DVD, it comes up like this. And it tells you what you have to do. It says, please enroll a hash of loader.efi, and you just press OK. It starts hash tool. As the first element there is enroll hash. You press enter, and you see this boot directory with loader.efi in it, and you have to select it. It's not 0 presses, but it's about as close as we can get without Microsoft telling me I'm doing a present user test.
So is this a once-only thing on a brand new virgin machine?
Yep.
If anybody's done anything else on the machine, you can never do this?
Yes, you can. This binary will always start because it's signed by Microsoft. The one thing it does is once you've enrolled the hash, it's enrolled into the MOK list, which is a non-volatile variable. So on the second boot, the hash will actually be there. So if I enroll the hash now and then I recall preloader, it will actually just all boot up because the hashes are all present. So this is a one-time thing you have to do to get the hashes into the MOK list, if that's the way you choose to do it.
Is it possible to dual boot?
It is, provided you preserve the Microsoft keys. The way to dual boot a platform is actually to take control, so remove the OEM platform key and put your own in. You have to leave all of the Microsoft keys in place. I'm not clear as to how many keys Windows checks for. It cannot check for the platform key because that's OEM specific. So you're free to take control of that. It may check to see whether a Windows key exchange key is present or not because it has access to these variables. And it's definitely going to check to see that you booted up with the Microsoft variables. So each of those 3 variables in DB has to be present. But you're free to add as many other keys as you want. So you can add your Linux distribution key in there if you want to, and your own personal key or whatever, and the system will happily dual boot in that case, yes.
I had a question about the kernel images. You had to put it into the hash table after you did the loader. Is that going to have to happen every time you update the kernel, or is it sort of automatic after you've done the first one?
So the distros have various ways of automating it, but I haven't built them into this. So in my view of the world, you would have to authorize a new kernel every time you installed one, and that would be a safety measure. It's perfectly possible to either automate the update, or instead of installing a hash, you could actually install your own key straight into the database, and then you just sign the kernel with that key. Part of the EFI tools that I haven't demoed here is not only does it come with a suite of EFI utilities that allows you to manipulate the keys, it also comes with a set of Linux utilities that allow you to take X509 certificates, create this thing, sign binaries, create key lists, create revoke key lists, and so on. So there's a full suite of tools for actually taking control of your platform. So you could build the signing of a kernel straight into your build system or into your install system. You could actually intercept the grub installer and actually have it sign the kernel before it installs it. Obviously, that requires access to your private keys, so it's something you should do carefully, but you can do that.
Hi, James. Thanks very much for the presentation. I have a question on the 2 protocols that you mentioned that are Dixie protocols, right, that you're relying on.
Yes.
And so in the UEFI forum, there is a guideline that actually says that operating systems or the applications of UEFI should not rely on the platform initialization protocols. But I think if you think that these 2 protocols are useful for to address your problems, have you thought about proposing to make these 2 protocols as part of the UEFI spec?
So the answer to that is no, because the Linux Foundation is not yet a member of UEFI, but once we are a member, it might be possible. I would imagine, well, I can't see Microsoft objecting. They could be documented as part of the EFI spec. That would certainly get Matthew Garrett off my back because he complains every time he sees me that I'm doing something non-standard. Mind you, he also hates gummy boots, so we have a lot of disagreements over a lot of things. So yes, it's absolutely something we could consider doing.
Yeah, the reason we have that guidance is that we want to make sure that for future systems we don't necessarily have to have PI implementations underneath. You have seen all the systems today are implementing PI.
Yes.
But we want to have this freedom. You never know what you're getting into later on.
Yeah, so proposing these as part of UEFI would insulate me from the problem that someone might actually come along with a blue sky implementation that doesn't do this.
Yeah, thanks.
Okay, so it's something
we've run out of time for further questions. I'm sure James will be around to answer questions if you guys have in the corridor or something. Thank you for your speech, James, and here's a small gift from Linux Australia and the conference organisers.
Thank you very much indeed. It's a pleasure.